So let me finish with the spillover from the morning session. I will present a couple of ideas, strategies, how you could go about debugging. And the main message I want to give you is really that debugging is easiest in the context of unit tests. So if you want to investigate a bug, the best idea is to write a test with the minimum example or a larger example and then try to minimize it. That triggers your bug, makes the test fail, and try to fix it. But maybe first some other strategies, right? I think we've all been guilty of doing something like this, right? We don't understand what is going on. We sprinkle a generous seasoning of print statements throughout all of our code, and then we don't really can tell where this print came from, so we add these in caps markers, which print is printing what. And this is, of course, simple to do. You can just start doing this in your own code, but you need to modify the code, in fact, right? And you end up with these print statements that you don't want to have in your actual code. They were just for debugging, so you need to remember to remove them again. So there has to be a better way than doing this. And what I showed you already a bit before in the testing is using the logging module. And here the advantage is that you basically can switch on and off very fine-grained what kinds of messages you want to see and which one are not shown. And by default, for example, only messages with a level of warning will be shown, and everything that's just debug and info will not be shown to you. But then if you are investigating an issue, maybe you rerun the code again, but you say that you also want to see the info messages or the debug messages. And you can even configure this per logger name. You can say, from this logger, I want only the warnings, and from this logger, I want the debug information, so that you can go really fine-grained and not be flooded in debug messages from modules that you know are working fine, but just the debug messages from where you suspect the bug. And there's also a nice integration with pytest here. So let me show this to you here, maybe in the Fibonacci tests. So I could add in this module here some logging. And convention is to, at least in libraries, to just use this name constant that is provided by Python in your module, which will give you the fully qualified name of the current file of your current module, and use that also for the logging statement. And then you can, and this really should be debug, right? You could say input n equals n here. And this is something you certainly don't want to get users all of the time when they do compute your numbers. But if you are debugging an issue, maybe you want to do this for debugging. Here you can say again, returning 0, returning 1. And maybe you change your code a little. Maybe you say the left side is this. The right side is this. And then you log. Or you even say the result is, and then you say left plus right equals result. And you might not be used to these older formatting instructions here in Python. You might also only be used to the format methods or the f strings, which are a bit more modern. The logging system is relatively old, and by default it uses the older style of formatting with these percentage characters. But the advantage here is that if you do this and for some objects, the conversion to a string that you can print might be expensive. This formatting is only done if the message is actually printed. So if you have your logger configured to only show you warning messages, this formatting will never be done for the debug message. So it's also some kind of low-level optimization that you don't do expensive operations when you don't actually need it. The format or the F string would be evaluated immediately, even if you never see the logging message. And now I could run pytest here, and it has an option to show logging, but if I set the log CLI level to warning, I won't see anything. Non-type and int. I broke everything. Oh, I need to return the result. Yeah, so everything passes and I don't see any messages. But imagine I have an error and I want to debug, and I can set the log CLI message to debug here. And then for each of these executions, I get the log messages of what I did in between. And you will see here that the caching also interferes with what log messages I get, because the logging is only executed when I'm not hitting the cache. So you can also understand, for example, why this was so slow without the cache, because of this doubly legged recursion. It does a lot of operations because it recurses in both times. It basically is exponentially growing in the size because each leg, again, recurses 2 more times. And yeah. And if you don't log, this finishes in a couple of seconds, but the logging operation itself is also expensive, right? It has to show you characters on the screen, and now it's logging a lot of time. So this actually interferes with your performance. So you need to weigh a bit. So I'm not suggesting you to add logging debug statements to all of your numeric code. It will absolutely tank your performance, but for high-level interfaces, maybe you can add some logging statements, inputs and outputs during debug. But that's, of course, a trade-off between performance and being able to get this information easily. Okay.
How do you enable or disable the debug message?
Sorry, can you ask the question?
Yeah, if you have all the debug information, but you don't want the debug information to be displayed.
Yeah, so here I passed to pytest this command line option with debug, right? And if I set it to warning, or if I just leave it by default, it won't show anything. And then it's also faster again, right? Because it actually doesn't print these statements. And the levels are, the default levels are info and then warning and error. So if I say warning, I only get the warnings, not the debug, not the info.
And if I'm using this kind of code in a notebook, is there a variable or something like that that I can use?
So I mean, I'm not really planned to give a tutorial on the login, but maybe you can just. It's the same in the notebook, so you can call this this basic setup function here, and you say logging.info, for example, and then you would get all of the info messages. But there's a very good documentation on it in the standard library, and lots of tutorials, so have a look. It's really useful. Yeah, and then the next big step, I already showed this integration with pytest, but you can also use it on your own, is using a debugger. And I have a bit of a constructed example here in my examples. No, here. Sorry, yes. Sorry, I need to find this example. Okay, maybe I just invented again. So I have a script here, and my idea was that I have, you know, this sync function, right? It's sine of x over x. And you have a problem here, right? If you enter x equals 0, the naive computation of this will return an error, divide by 0 exception. But actually, this is well defined at 0. It should be 1. You can compute this with L'Hopital's limit rule, and you will see that in the limit of x equals, x goes to 0, you actually get 1 when you divide the sign by x itself. So maybe you have a simulation model that does some computation 5 times sync x, and you have another code that just simulates by summing up several of these calls. So maybe it's sum model x for x in 0.1, 0.5, 0.0. Yeah. And now you have the situation where if you do this actually, right? So if you say, I want to simulate, this is very constructed, I have to admit, but I mean, you get a very long stack trace here, right? You need to understand what is happening. So you get a division by 0 error from this sync function, but you didn't really call the sync function yourself. You just called the simulate, right? And then you see, okay, what is it? So in model, I have 5 times sync, and I have then model x is called for x in 0.1, 0.5, 0.0, and that happens in the simulate function. And it's a bit hard to understand. I mean, now the example is relatively simple, just 3 layers. But what you can do is you can run this in the debugger, and you do this by doing Python -m pdb, and then you run the script. And that brings you into the debugger, and it's now at the first statement in the function. And what I can do is I have a couple of options here. I can just continue with the script execution, and that will run my full script. And it will just go back into the debugger when it hits an exception or the script is just done. So we could do this now. And then it will just execute until it hits this exception. And now I can, for example, look around in the code. So it shows me where in the current execution I am. And it shows me, okay, the exception happened here in return mass of sine x divided by x. And I can see that what is x? X is 0. Okay, sure, that creates this exception. But why is x 0? So I can go up 1 level in the stack trace. And then I see, oh, this was called from the model function of x, 5 times sync. And again, print x here is 0. And I can go 1 layer up again in the stack trace. And then I'm now inside of this the sum expression, and I have x again, and again 1 layer up, and then I'm now outside of this expression, and I don't have x, I just have the data, right? X is not defined because I'm now outside of this loop, but I can also go down again, down again, down again, back to the original part of the exception. Let me go out and do this again. What is also very helpful is not just running the script, but really stepping through the execution. So there's one command here which is step. And this will not just run everything until something happens. It will really go one by one through the execution of the step. Defining the functions, the if, the call to simulate. Now I am in simulate. Now I am in this function, and I'm still calling the loop. And now I'm in the model, in the sync. And this time x is 0.1. So this works. And I step through the execution. X is still 0.1. Now x is still 0.1. And now I'm at the next x value in the next iteration of the loop. And I can really step through the different steps of my program one by one to see what is happening. And then at some point I can just say, okay, now I understand what happens. I need to do this. And then the script just works. And of course, this is a very simple example, but this debugger is immensely powerful to step through this. What you can also do is, I showed you that you can step through, right? That is very fine-grained. And I showed you that you can run, and then it stops at the exception. But what you can also do is you can insert a breakpoint here, and then you can run, and now it will stop at the breakpoint. You can see where you are in the code. You are at this breakpoint here now. You call x, it's 0.1. We continue. We hit the same breakpoint again because we are in this loop, and now x is 0.5. We continue again. We hit the same breakpoint again, and now x is our problematic value of 0. And when we now continue, we stop at the exception, and we can again investigate why this exception has happened.
What are you recommending? You insert the breakpoint, but if I remember well, in the PDB you can you have a command which is b, and that break, and then you get the number and you put the number after the b. Yeah. What is your suggestion?
It depends a bit on if you have the code under your control or if you are debugging installed package that you can't modify, right? If you are anyway developing your own code, I think it's mostly easier to have it open in the editor and insert the breakpoint function. If it's already running code, if it's installed, then you have no other choice but to use the debugger and give the file name and the line number to insert the breakpoint, unfortunately. Yeah. And of course, again, with Git, right, you don't want to commit this breakpoint because otherwise you break the software, right? Everyone will just stop at the breakpoint when they run it.
So only if they run debug.
No.
Like it skips breakpoints. I think if you run Python, it should skip.
If I just run this, I'm also
Okay. It jumps into the
Are you able also to make conditions with this kind of procedure with the breakpoint?
Sorry, what?
Are you able to make condition on the breaking, sort of breaking condition? Meaning, okay.
I think you just use conditions in the code and call the breakpoint if you have the condition.
Okay, because with the b command, there is an option to do it.
Yes, and this is what I already showed you. There is a nice, if you are using IPython, you can also configure pytest to drop you into the IPython debugger, which has a better syntax highlighting, works a bit nicer, has some more features than PDB, and you can have this pytest minus PDB integration where it also will step you through the breakpoints and dump you into the debugger when an exception or a test failure happens. We have seen this before. Yeah, and this is all I have for debugging. And we now enter the exercise session, where I have to apologize a bit to you because I'm now basically dumping a bit big experiment on you that you might have encountered in your real life. I give you a historic code base with absolutely no tests and ask you, please add some tests, make sure that it works. So if you update the pkoffee repository, you should get the solution of yesterday. And this included the refactoring into the different modules, the API layers that Vincent presented yesterday evening, but there's still no tests, right? So the idea would be that you continue working in the groups, pushing to your group forks and add some tests. The first thing that you need to do, pkoffee, is probably update. Yes. So now there is the proper coffee layout, the source layout, the Py project, and Pixi toml. But there is, for example, no test integration yet. So the first thing that we should probably do is define that we want to use pytest here for testing. And maybe we also add pytest conf. You need to add them to the dependencies? Yes. To the dependencies? I need to add them to at least one environment that I want to use. So maybe we just add it to the default because our default is for development, right? So the prod only has the these ones, and then the default has everything. And we could also add a task here. So feature.test.tasks. Test equals pytest. Doesn't find any tests. Huh? Pixi run test. Yeah. Okay, so the setup works, but we don't have any tests yet. This is maybe a good point to discuss something I completely forgot to mention in the slides. It's where do you put the tests? I think I forgot to mention this because I think last year we had a lecture on packaging, and there I mentioned where we put the tests when we want to package our modules. I now realize that we forgot this, but there are two options. So if you look at the repository here, so you have the analysis, you have the coffee, you have the top-level project files like the log file, the Py project, the README, the license. And then we have our module here in source pkoffee, and let me increase this by 1. So you see there's all the Python files here, right? And now there's two approaches. One is to create a top-level directory here next to it, and then write tests there. Test. And then the idea would be, okay, we maybe test the metrics or the whatever else we have. And maybe we just, for now, test that it imports. And we have our first test. And that is the one structure that many people use. So you have, if we show this again, you have your source Python module, and you have your tests next to it. The other option is to move the tests inside of your Python module, inside pkoffee. And you also create such pkoffee tests init.py. And now I need to increase the level again. So we have the tests now here, and they look like a valid Python module. They are just part of our Python package, and we have a sub-module called tests, and there's all of our test functionality. And the advantage of this is that the tests are going to be packaged as part of your application, and you can do something like install without having the source code available, without being anywhere, right? You can do pytest, pyarg, pkoffee, pyargs, and I don't have the pkoffee actually, shouldn't it? I'm not in the environment, sorry. Pkoffee, Pixi shell. So now I'm out of the repository, right? I don't have access to the local test files. I'm just in my home directory. But because the test files are part of the packaged Python module, I can run the tests that are installed in my Python environment. And that's the main advantage of having the tests inside of the module versus outside in parallel. If you have tests that don't actually work in an installed fashion but need some data, test data around that you don't expect your users to have, you probably put them outside. But I think the default should be you should try to have, especially for numeric code maybe, where the platforms are different, you would people to be able to, after they install your module, run the tests on their machine and see if they work.
Most of the time, you want to give the test to the people?
I would say yes.
Yeah.
So if you don't have strong reasons against this, I would recommend to you start with this approach of putting the tests inside of the Python module. And now I created a subdirectory called tests here. This is now a relatively flat module, right? So you have pkoffee, and then we only have file modules. We don't actually have deeper packages. If you have a large module, for example, there's fit model here and fit model IO. These belong together. So maybe we have source pkoffee fit model, and then we move source pkoffee fit model.py to source fit pkoffee fit model init.py, and pkoffee fit model IO to source pkoffee fit model IO.py. And then the convention would be, if I have such a sub-module, sub-package here, I would also put the tests for this module inside of there. So below the fit module, I have again a tests directory with the tests for this package. Okay, but now we have until lunch, I think, for these exercises, so you can get familiar with the code, think about how you would test it, what are the most important pieces, maybe to add a couple of unit tests first. Maybe the model is a good point to start, right? You can check if the fit function really computes the correct values, if you get the correct input parameters. It should be easy to check with a calculator app or so that the implementation is correct.
I added a few steps for the exercise in the Slack.